Welcome pre-cal students to class today on Friday the 17th. Hope you guys are doing well and hope you're ready to finish the week. Go ahead and get your things out for notes today, books, calculators, pens, pencils, and notebook. And let's quickly go over some announcements here that I think are very important, so please listen carefully. First of all, you have a quiz on Saturday. And I'm going to go over what will be on the quiz in just a second. Look at announcement 2. There's no class Monday. Now we stick to Hamilton County schedule, and they don't have school on Monday either. Now we don't go as many weeks. I mean, we go 18 weeks, but we don't start and stop exactly when they do. But when they have days off, spring break, fall break, Christmas break, days off, President's Day, whatever, we take those days off. So there will not be class on Monday. Now I emailed all this to your parents earlier when I sent out the semester schedule. So I want to tweak one little thing. I've been telling you guys all along that your quizzes from now on will be due on Tuesday. Because of this day off on Monday, and because I have no idea what our plans are, you might want to come see me Monday, and I might say, no, we're going to be out of town, or we might not be. But because there's no class on Monday, I am going to delay your turning the quiz in just this one time, one extra day. So your quiz will be due Wednesday. In my hand, all questions asked, completely finished, okay? No class on Monday. Now what that means is you were not coming to my house anyways. When I say no class, really what I mean is no video. You weren't supposed to come to my house. You're not coming to my house until a week from this Monday, because we want to wait until we have 2 weeks of material under our belts before we take a test. So this Monday, no video, no class, day off, just like Hamilton County, and your quiz will be due Wednesday. Please stay on top of your integrity sheets when you come to my house to take a test. Remember, everything has to be turned in then. What's not done, you will get zeros. And there'll be no homework over the weekend, so pretty good news for you guys. The video is really long. I want to warn you now. We're going to cover a truckload of math today, but I'm not going to give you homework. On Monday, I'm just going to give you homework, and I'm not going to teach a lesson. Or not Monday, I'm sorry, on Tuesday. So when you start looking for Tuesday's notes, please listen to me. Next Tuesday, when you go to look for a video, it's probably going to say something like pre-cal, January 22nd, and then it will say homework. Okay, because there's not going to be a video. Actually, I'll tell you what, there might be look for 2 videos. There might be a quick announcement video, like a 2-minute video making announcements and then telling you to watch the homework. So yeah, there will be 2 videos. One will be like 2 minutes long and the other one will be the homework video. So because the lesson is going to be so long today, and because homework assignment is very long too, I'm breaking it up into 2 days to totally balance that out and make it fair. So the video will be long, but no homework over the weekend, and there will be homework only on Tuesday. Okay? Call or email if you have any questions on these announcements at all. Oh, let's go over your quiz. Okay? It's really simple, guys. It's really simple. We had class on Tuesday, we had class on Wednesday, and we had class on Thursday. Now usually Friday's material would be on the quiz, but since I'm not giving you any homework to practice today's material will not be on the quiz. So all that I can say is very easily, anything from your homework from these 3 days is fair game for the quiz. So make sure you know how to work out all the problems on Tuesday's homework. Make sure you know how to work out all of the homework on Wednesday's homework, and make sure you know how to work out all of the homework problems on Thursday's homework. Okay? That is what will be on the quiz. If you have any questions on that, call or email me. Okay? And with that in mind, let's get to work. Here we go. Please get ready to take a lot of notes and learn a lot of math. Even though the video is long, remember, you won't have any homework on this math until Monday, and that should say Tuesday. So let me fix that real quick, okay? All right, let's continue on. We are going to be looking today at arithmetic sequences and series. Now, students, we've been looking at sequences and series, but now we're going to look at a specific type. And this type is called an arithmetic sequence and an arithmetic series. Please copy your heading down. The heading is Arithmetic Sequences and Series. The lesson number is 10.2, and the date today is the 17th. The date today is the 17th. Now, remember my philosophy, I go fast, and you will have to pause the video some. Okay, let's start off with the definition of what an arithmetic sequence or series is. All right, here's the definition. Write this down. It's a set of numbers that has the same number being added to each term. That's it. An arithmetic sequence is a set of numbers that has the same number being added to each term. Okay? I think a picture really helps. Here is an example. This is an arithmetic sequence. Write this in your notes. -3, 1, 5, 9, 13, 17. Now, why is this an arithmetic sequence? Because we're adding the same number over and over and over. -3 plus 4 gives you 1. 1 plus 4 gives you 5. 5 plus 4 gives you 9. 9 plus 4 gives you 13. 13 plus 4 gives you 17. Do you see how we're adding the same number over and over and over to get out the next term? Isn't that simple? That is so easy to understand. You have an arithmetic sequence, not when you're multiplying the same number, not when you're dividing the same number, but when you're adding the same number to each term. Then that sequence or series is called an arithmetic sequence or series. Let's continue on. Now, a little redundant here, but notice that the number that is being added over and over is 4. Now, this next part is so important. Please don't miss this. We call this the common difference. And by the way, we denote that with a little d. So in your books, you'll see this right here. You'll see this right here. D equals 4. For this sequence, D equals 4. And that means the common difference is 4. It's not CD, it's just D. D means common difference. Look at this. Every arithmetic sequence or series has a common difference. If it is an arithmetic sequence, if it is an arithmetic series, it will have a common difference. It will. Okay? So 4 is your common difference. Let me throw 3 problems at you and let's see how you guys do. Okay? Here we go. For the following 3 arithmetic sequences, find the first term and find the common difference. Okay, let's start off with this first arithmetic sequence. Obviously, the first term is 4. That's easy enough. There's the first term, so we found the first term. Now, the next thing we're going to do is we're going to find the common difference. So D equals. Now, to me, it's obvious to see that we're adding 5, 5, 5. But if you ever can't figure out what the common difference is, just simply pick any number in the group, I don't care where it is, and subtract the number to the left. And if you do that, you'll always get the common difference. Isn't that easy? So, 14 minus 9 is 5. So there's your common difference. Or you could have circled, and this is wrong here, hold on, 4, 9, 14. I'm not sure where this 24 came from. This should be a 19. That's a typo. But anyways, so you could circle 19 if you want to, and then subtract the number before it, you'll get 5. You could circle 9 and then subtract the number to the left, and you'll get 5. Either way, the common difference is 5, because 5 is the number we're adding over and over. Okay, let's take a look at sequence number 2. Let's first of all find the first term. Well, obviously the first term is 34. That's easy enough. And then what would the common difference be? Well, some of you can probably do it in your head. You can see that we're adding a -7 over and over. 34 plus a -7, 27 plus a -7, 30 plus a -7, 13 plus a negative. But if you can't see that on your own, circle any number you want and subtract the number to the left of it. So -1 minus 6, that would be -7. Or circle this number and subtract the number from it to the left. So 20 minus 12. 27, negative 7. So I hope you're seeing how to do this, okay? You have to be able to find the first term, and you have to be able to find the common difference. Okay, let's try this one right here. Obviously, the first term is 2. That's the easiest part of these problems. And now the common difference would be, well, it looks like we're adding 1/2 over and over and over. 2, then 2.5, then 3, then 3.5, then 4, then 4.5. So my common difference is 1/2. Now, if you struggle with seeing that, circle any number you want, like 3.5, and subtract from it the number to the left. So 3.5 minus 3. And that would give you 1/2. Okay, so that's a pretty easy way to find the common difference. And so let's continue on. Okay, just learning terms here about arithmetic sequences. All right, now remember how we were finding nth terms or general terms earlier this week. Remember? Well, here is something really cool. If you have an arithmetic sequence, you can find the nth term without really any hard work at all. There is a formula you can use. So if you know you have an arithmetic sequence and you want to write the nth term, there's a formula you can use. And here's the formula. Please copy this down. Here's the formula. And this formula is, in case you want to label it, it's for the nth term. And you probably should label this in your notes, of an arithmetic sequence. All right? Nth term of an arithmetic sequence. There's your formula. Okay? It is a subscript n equals a subscript 1, or your first term, plus n. Now n's going to stay there. N of course is supposed to be in your nth term, so n would stay there, minus 1. That's a 1, and then your common difference goes here. So anytime you want to find the nth term of an arithmetic sequence, let me grab a quick drink here. It looks like to me you only need two things. You need the first term and the common difference. That's it. So all that you need to use this formula is the first term and the common difference. If you know those two things, you can write the nth term so easily. All right? So let's practice using this formula in the problem below. Find the nth term of the arithmetic sequence. Now again, I'm asking you to write the nth term. Now you could try to do this on your own, okay? And you could probably figure it out. But there's a faster way. When you know you have an arithmetic sequence, use this formula right here. All right? So when you're using this formula, you need two things: the first term and the common difference. So let's write this down. The first term of my arithmetic sequence is 4. My common difference is 3, because you're adding 3, adding 3, adding 3. So here's your formula right here. Everybody see it? Here's your formula right here. So a subscript n equals a1, that's your first term, so I'm going to put a 4 there, plus, and then n minus 1, close your parentheses, and then your common difference, 3. Now a lot of students like to do this, and I'm okay with this. But hold on, before I get into that, there's your nth term. You did it. It took no, listing out the terms up top and looking for a pattern and trying to figure it out. If it's an arithmetic sequence, just use this formula right here. Now, a lot of students do like to put the 3 here, and then the parentheses. And to be honest with you, that's a little more normal there. I kind of like that better, but I don't care. No big deal. This book has the 3 going at the end right here, and that's fine also, okay? But either way, there's your nth term, all right? Now, this is pretty interesting. Let me go back a page and drag this thing over so we can use it. Okay, now take some notes on this if you need to. Now, here's your arithmetic sequence: 4, 7, 10, 13. See that? Now I want you to find the 157th term. Now, can you imagine that? Come on. Can you imagine trying to count? Can you imagine trying to count going by threes until you got to the 157th term? Of course not. So now do you see why it's so helpful to know the nth term? Remember, if you know the nth term, you simply put in that term number in for n, and you can get out what the term is. So I'm going to say that term 157 equals 4 plus parentheses 157 goes in for n minus 1 times 3. And then it would be 4 plus 156 times 3. And then it would be 4 plus, let's see, 8 carrier 1, 6 carrier 1, 4, 468. And then add those two together and you will get 472. That was a lot faster than trying to count over to the 157th term. Now, the reason I gave you this problem is I just wanted to review with you why the nth term is so helpful. Okay, it's really, really, really helpful to know. And if you have an arithmetic sequence, you can find the nth term by using this formula here, and it's really fast. And once you know the nth term, you can then find any term in the entire arithmetic sequence. All right, let's continue on here. I have a feeling that we're probably going to need this for the next problem. Let's see if we do. Yes, we do. So let me quickly grab this and we'll pull this over for the next problem. And it's just not going to work, is it? Okay, there we go. All right, let's continue on. Okay, let's take a look here at this problem. We can do some really cool stuff with this formula. For example, think about this. This is really interesting. Watch this, students. Watch this carefully. One of the terms in the above sequence, this sequence here, one of the terms in the above sequence is 76. In other words, if you keep going out far enough, sooner or later one of the terms will be what? 76. What term number is 76? For example, 4 is term number 1, 7 is term number 3, 10 is term number, or 7 is term number 2, 10 is term number 3, 13 is term number 4, 76 is term number n. We don't know. So with this formula, you could actually, instead of finding the actual term, you can find the term number. And you're probably like, well, how, Mr. Hart? Well, let me show you. A subscript n, that's the actual term we're looking for, and that's 76. They gave that to us. They told us one of the terms is 76. So I'm going to put 76 for A subscript n. And now I'm going to solve for n, because remember, n is the actual term number, not the actual term. Okay, the actual term is 76. But what term number that is n. So now that I've put 75 in for A subscript n, I can now solve for n, and I will know what term number 76 is. So n minus 1 is 3. Now take your 3, and you're going to multiply it through the parentheses. So 3 times n is 3n, and 3 times negative 1 is negative 3. Now, let's continue. We have 4 plus 3n minus 3. Combine your like terms. That's 1 plus 3n. And then bring the 1 over and make it negative. And actually, this should be a 76 all the way through here, shouldn't it? I apologize to you. It's totally my fault, and I'm very sorry. That should be a 76 all the way through there. Now bring your 1 over and make it negative. You get 75 equals 3n, and then divide by 3, and 25 equals n. So now I know 76 is the what term? It's the 25th term. So if I would have counted over all the way to the 26th term, I would get 76. Okay? Pretty cool. There's a lot of stuff, students, that you can do with this formula. Okay? Let's continue on. And I think my button there just kind of froze on the Mimeo pad. Hold on one second. All right, let's try another angle on arithmetic sequences. This will be really, really, really interesting. The third term of an arithmetic sequence is 8. And the 16th term of the same arithmetic sequence is 47. Now, I want us to find the first term and find the common difference, and then construct the sequence, or in other words, write out the sequence. So let's see if we can't figure this out. Now, I would like to work this problem out without drawing any pictures. And that's really the fastest way to do it. But since this is the first time we've ever done a problem like this, I'm going to go ahead and draw a little bit of pictures here and help you guys see how to do this. Now, we know the third term is 8. So watch what I do. I'm going to put a blank and a blank for the first two terms, and then put an 8 for the what term? The third term. And I know what the 16th term is, so put some blanks here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then here's term number 16, which is 47. There we go. Now, I want to show you something. Please watch this. From 8 to 47, this is 8, and this is 47, right? From 8 to 47, I have a distance of 39. How did I get that? I just subtracted. Come on, think about it. I just subtracted, okay? So I have a distance from 8 to 47. That's 39. In other words, from the number 8 all the way to 47, I would have to add 39. So if I was going from 8 to 47, what number do I have to add to 8? 39. Do you see that okay? Now, look at this. This 39 that I would have to add from 8 going all the way to 47, I can take that 39 and divide it up into 13 numbers. How do I know it's 13? Well, 8 is your what term? 3. 47 is your what term? 16. That means there's 13 terms, or 13 spaces. Now, if you count the blanks, watch this. If you count the blanks, watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You only get 12, okay? So you're like, well, I think we should take 39 divided by 12. Hold on. You got to count the gaps. Remember, 8 plus a number gives you this, plus a number. I'm going to use a plus sign. Plus a number, plus a number, plus a number, plus a number, plus, 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 plus. In between these numbers, I'm putting plus signs. And now count those plus signs up. 13. And that's why we take 39 and divide it by 13. Now again, I really didn't want to draw a picture. It's a faster way just to subtract the 8 and the 47 and get 39, and then subtract the 16 and the 3 and get a 13, and then divide the two. But I wanted you to see why. You have to add 39 to 8 to give you 47. That means the total number you're adding from term 3 to term 16 is 39, and then divide that by 13 because there's 13 plus signs. You're adding a number 13 times, that's going to give you 39. So we divide 39 by 13, and that gives us 3. So now I know what I'm adding. Now I know I'm adding 3 over and over and over. Let's see if I'm right. Real quick, we can add 3 real quick. Let's add 3 and see if we hit 47. 17, 20, 23, 26, 29, 32, 35, 38, 41, 44, booyah, 47. Okay? So we found the common difference. That was one of the things they wanted us to do. They said find term A and D and construct the sequence. So we found the common difference. D equals 3. That's what we're adding over. Good. Now we can find the first term. Let's subtract 3. So 5, subtract 3, because we're going backwards now. 2. So there, now we found the first term. Look at that. Look at that. And then construct the sequence. Well, we did that. My goodness. Look at all these terms we wrote. We totally constructed the sequence. There it is. Look at all these numbers. So we constructed the sequence. So all these problems on Monday or on Tuesday, when you come back to class on Tuesday and you work on the homework, students, I'm going to give you a ton of problems like this. You'll probably have about an hour of homework. However, you won't have a video to watch, okay? And so it's kind of give and take. But we're practicing all these different angles so you have a better understanding of what we're trying to do here. Okay? All right, let me grab a drink here and we'll continue on. We've spent all of our time so far looking at arithmetic sequences. Now remember, when you take a sequence and put plus signs between each number, do you remember what it becomes? It becomes a series. Let's focus now our studies. Let's focus our studies now on arithmetic series. Okay, so we've been looking at arithmetic sequences. In other words, all of these problems have not had plus signs between the numbers. And now we're going to look at arithmetic series in which there are plus signs between all of the numbers. Here's an arithmetic series. Now I know this is a pain, but I'd like you to quickly, even if you have to pause the video, which you probably will, I want you to quickly write down these numbers. Okay? Now, watch this. This is so cool. Watch this. If I take the first number, oh, let me back up. If I ask you to add all those numbers up without a calculator, that might take a little bit of time, but can I show you something real quick? Watch this. If I take the first term and the last term and add them together, what do I get? 53. If I take the second term, I'm just going to circle instead of drawing all these lines. If I take the second term and the next to last term and add them together, what do you think I get? 53 again. Cool. And if I take the third term over and the third term over and add them together, what do you think I get? Yep, 53. And if I take the fourth term over and the fourth term over and add them together, I get 53. Guys, that works with any arithmetic series. If I just had 1 plus 2 plus 3, did you know I could add the numbers 1 plus 2 plus 3 all the way to 100, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, all the way to 100. You can do that very quickly because 1 plus 100 is 101, and then what would be right before 99? 199. So 2 plus 99 is 101, and then 3 plus 98 would be 101, and all you have to do is find out how many sets of 101 you have and multiply it and you're done. It would take about 1 minute or less to add up the numbers 1 through 100 without using a calculator. So Mr. Earhart, why are you showing this? Because I'm going to show you in a second that we have a formula that will help us solve arithmetic series so quickly. It's really helpful, but I want to show you where they get the formula from. They get the formula from realizing if you have a true arithmetic series and you add the first number and the last number, and then the second number, the next last number, and the third number, and the third last number, you will get the same number over and over and over. It might not always be 53, but whatever number it is, it'll be the same number. Then all you have to do is find out how many sets of 53 you have, and then you're all set. And so that's basically what the formula is founded on. Okay, so I want you to see that. And this formula that we're going to use dealing with arithmetic series really helps us find the sum quickly. It really does. And here's the formula. Here it is. So please copy that down. This is the formula, if you want to label it, that helps you find the sum of an arithmetic series. Now students, please listen to me. If you try to use this formula on a series that's not an arithmetic series, it won't work. Just like this back here, the formula I gave you way back here, nth term formula. If you try to use this nth term formula on a sequence that is not an arithmetic sequence, it won't work. This formula right here is the formula that gives you the nth term for an arithmetic sequence. Well, this formula right here is the formula that gives you the sum of an arithmetic series. It has to be an arithmetic series. So it looks like to me all that you have to know is how many terms you have and what the first term is. And I believe when I copied this down, I'm pretty sure this right here, and I'm sorry, we all make mistakes. Yeah, this should be an N right here, and I'm so glad I caught that. I mean, I know that. I've taught it for years, and I just noticed that when I was going over this. So that should be an N right there. All right, and I'm going to show you what to do with all of these terms here in just a second, but this is the formula that you would use. Now, let's use the formula on the above arithmetic series. Okay, so here's my arithmetic series. Let's very quickly see if we can find the sum of this, adding all these numbers together without using a calculator. Okay, first of all, we have how many terms? I think it's 18. 18, yes. So see this sum, this S subscript N, you put S 18, that means a sum of 18 terms. So what is your N? 18, got it? A sum of N stands for how many terms you have, 18, equals, well here's an N, so 18 over 2, all right? And then A subscript 1, oh this should be an N right here. A subscript 1 would be a 1, that's your first term, plus A subscript N. Now don't forget, what are we putting in for N? 18. So it's really A subscript 18, which is your 18th term, which is 52. And there we go. 18 divided by 2 is 9. 1 plus 52 is 53. And then multiply those two together. 27 carry your 2, 477. And isn't that basically what I was showing you before? I was saying if you take the first term and the last term and add them together, which is what we did right here, 53, and then they found out how many sets of 53 there were by taking the total number of terms and dividing it by 2. So there were 18 terms divided by 2, that's 9. That means there's 9 sets of 53 in here. And so there's your total sum. So again, if you didn't understand all of my explanation as to where this formula comes from, don't worry about it. You can use the formula without understanding all of those details, although I hope that you do. But all that you have to do here is be able to make substitutions and solve, and you can find the sum pretty quickly. Okay, so this formula helps you find the sum of arithmetic series. Let's continue on. All right, let's take a look at 3 more problems and then a word problem. All right, hang in there, we're almost done. And remember, there's no homework for over the weekend, okay? Just a video like this today. Let's start off by finding the sum of the first 100 natural numbers. Now, natural numbers, of course, start with 1. And they're going to be integers also. So let's kind of get a picture of what we have. We have 1 plus 2 plus 3 plus, and then dot, 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 and then plus 100. So there we go. We're going to find the sum of this. Now I have a question for you. Is this an arithmetic series? The only thing we have to have for an arithmetic series is to be adding the same number over and over and over. And yes, we're adding 1, we're adding 1, we're adding 1, we're adding 1. So we definitely have an arithmetic series. Okay? So we can use the sum formula for an arithmetic series. And here it is. It's n divided by 2, and then it's your first term plus your last term. All right, so we're doing 100 terms, okay, from 1 all the way to 100. And so it's S subscript 100 equals 100 divided by 2. And then your first term is 1, and your second term is 100. So now I would have 50, 100 divided by 2, times 101. And then 50 times 101 gives you 5,050. Isn't that easy? Students, listen to me, please. All that I had to do was establish one fact, that I have a what type of series? Arithmetic. I mean, as soon as I knew that I had an arithmetic series, then I knew I could use this formula to find the what? To find the sum. And this formula is so easy. Now, always check and make sure, and of course to have an arithmetic series you have to be adding the same number over and over, and we were. Alright, let's try another problem. find the sum of the first 15 terms of this arithmetic sequence. Okay? All right, now there's a couple ways. First of all, we do have an arithmetic sequence because they tell us we do. Okay? Now, we could put 4, 7, 10, 13 like that and count out all the way until we get to the 15th term. And that would be fine to do. It would take just a little bit longer, and it's not a bad idea. But since we're learning how to write nth terms of an arithmetic sequence, then let's go ahead and use that formula we learned way back here. Let me copy it and bring it over to this page if I'm able to do that. I hope that I am. I'm not so sure that I can do that, but we'll try to. Yeah, I don't think it's going to work. So, well, we'll do this here. And what I want to do here is I just want to kind of practice using this formula, okay? So, yes, I could find the fit. Remember, you say, well, Mr. Earhart, why do I need to find the 15th term? Well, remember, if we're going to find the sum of the first 15 terms, then here's what we need. We have an arithmetic series, so we can use our sum formula. So we know we have 15 over 2, or n over 2. And then in the parentheses, you put the first term. But then remember what you put here? You put the last term. And the last term is the 15th term. So I cannot put in my 15th term right here until I find it. That's why it's important that I find the 15th term. So I'm going to quickly write my nth term and then put 15 into this and get out the 15th term. Okay? So let's find the nth term of this arithmetic sequence. Here we go. A subscript n equals my first term 4 plus n minus 1 times, and the common difference is 3. There, I wrote my nth term. Isn't that so easy? So there's my nth term. Now, because I have the nth term for this arithmetic sequence, now I can find any term I want. And what term do I want to find up here? I want to find the what term? The 15th. So I put a 15 right here for n. So 4 plus parentheses 15 minus 1 times 3. Well, obviously 15 minus 1 is 14. And 14 times 3 is 42, so 4 plus 42, and add those together and you get 46. So there, I found the 15th term. Now you could have kept adding and you probably would have been faster than me. So Mr. Earhart, why are you wanting us to use this method? Because what if I would have asked you to find the sum of the first 212 terms? Then that means you got to go out here and find the 212th term. That's going to take you all day and all night to list out 212 terms. So learn to write the nth term, and then once you've written the nth term, you can find any term you want by substituting that number in for n. So that's why I did this. Now, we see the 15th term is 46. So now I'm able to, and I'm going to go ahead and erase this and put the formula so we're not confused. The sum formula is S subscript n equals n over 2, and then your first term plus your last term. In this case, it'll be term 15. So the sum of 15 terms equals 15 over 2. A subscript 1 is 4, plus A subscript 15 is 46. Add these two together and you would have 15 over 2 times 50, and of course you could use a calculator if you want to, and the sum you will get out, if you take 15 divided by 2, you get 7.5 times 50, you get 375. So you found the sum of the first 15 terms, it's 375. Now Mr. Earhart, I could have listed out the first 15 terms and added them up quicker than all of this that we did. Sure, you're right, I agree. But what if I would have asked you to find the sum of the first 85 terms? You better get used to using these formulas, okay? Because they're really, really, really helpful. Let me review real quick. This is the formula that helps you find the nth term of an arithmetic sequence. This formula here helps you find, as long as this is an n right here, let me put an n. This is the formula that helps you find the sum of an arithmetic series. Okay? All right, let's take a look at this problem here. Now, in this case, look at this, guys. I'm going to find the sum starting with 1, going all the way to the 130th term. Can you imagine that? Now, first of all, don't assume that you have an arithmetic series. We don't know. So let's find the first 2 or 3 or 4 terms, and let's see if we have an arithmetic series, okay? Let's put 1 in for k, and you would get out 9. Let's put a 2 in for k, and you would get out 13. Let's go ahead and get rid of that comma. It should be a plus sign because it's a sigma notation. All right, let's put a 3 in, and we get a 17. Let's put a 4 in, and we get a 21. Let's put a 5 in, and we get a 25. I think I'm seeing the pattern. Are we not going to keep adding 4 over and over and over? Yes, we are. So because we're adding the same number over and over and over, we have an arithmetic series. Do you see it? Look, all of these numbers are doing what? Adding. And so we know we have a series. Whenever numbers are being added, we call it a series. And we know it's an arithmetic series because notice the numbers are increasing by adding the same number. And so here's what I have. I want you to find the sum of these terms going from term 1 all the way to dot, 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 all the way to term what? 130. So the only way to find the 130th term is to put 130 in for k right here, and to get out what that 130th term is. Okay, that's the only way to do that. So if I'm going to put in, let me look here real quick. If I'm going to put 130 in, I'm going to get out 525. All right, so my 130th term is 525. Now, if I'm going to find the sum of this, I have to use my sum formula, which is s subscript n equals n over 2, and then it's my first term plus my last term. So in this case, it'd be term 130. So this isn't too bad. First of all, I note that I have 130 terms. So s 130 equals 130 divided by 2. First term is 9. Last term is 525. 130 divided by 2 is 65. 9 plus 525 is 534. So all that I have to do is take 65 times 534, and I will get 34,710. Do you like how I did that in my head? Of course I did not. 34,710. So again, this whole class period we're just practicing using these formulas, okay? All right, one more problem and we're finally done. So well done today, and you will not have to watch another video now until Tuesday. Now you will have a quiz tomorrow, so you better study for your quiz, okay? But we will not have another video until Tuesday of next week. All right, page 859, number 9. Let me get a quick drink of water here and we'll continue. Go ahead and turn your books to page 859. Let's take a look at example number 9. I will read it as you might want to pause the video. It's up to you. I'll read it as you're turning there. I'm going to kind of paraphrase. You have a stack of telephone poles. You'll see the picture in the book there. There's 30 poles in the bottom row, 29 in the next row, 28 in the next row, so on, until we have 5 poles in the top row. They want to know how many poles are in that entire stack. So basically you're adding 30 plus the next row, 29 plus the next row, 28 plus the next row, 27 plus the next row, 26, all the way plus dot 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 until you get down to the last row, 5. Now, because you're increasing by 1, let me go back a page. I'm going to show you a concept that is really, I dread it because it's so hard for students to see, but I'm going to try to show you. Can I show you something here, students? Please watch this. You knew Now we'll get back to this problem here in just a second. Let me show you something, because I'm going to show you something here that you're going to need for the word problem. You knew you had a total of 130 terms. You knew that, okay? Because you knew you were starting with 1 and going to 130. 1 to 130. But can I show you something? If you would have subtracted these two numbers, if you would have said, okay, I start with term 1 and 130, I'm going to subtract those two. 130 minus 1 is 129. So I must have 129 terms. You would have been off by 1. Do you see that? You would have been off by 1 because there's really 130 terms. Let me show it to you another way, and please, please watch this. Watch this, please. That's a really good drawing. Look, if I had numbers, if I said k equals 1 and we're going to the third term. No, let's change that. Let's say we're going to start with 2 and we're going to go to the 8th term. Okay? Now a lot of students would subtract this and think they have 6 terms. 8 minus 2 is 6, so I have 6 terms. So really, let's see. Here's the first term. Here's the second, third, fourth, fifth, sixth, seventh, 8. There's your 8 terms right there. And we're going to go from 2 to 8. So cross that off. So here's term number 2, here's term number 3, number 4, number 5, number 6, number 7, number 8. Now 8 minus 2 is 6, so you would think you would have 6 terms, but you don't. Count them. 1, 2, 3, 4, 5, 6, 7. You always have one more than what you subtract. So back here, if I would have taken 130 minus 1, you get 129, but you always have to add 1. It's always going to be 1 short. So I know I have a total of 130 terms. Let's apply that now to this. A lot of students say, okay, we're going 30, 29, 28. So if I take 30 minus 5, that must mean I have how many terms? 25. No, that is not correct, okay? You have to add 1 to that and get 26. So I know for sure that I'm going from this term here all the way to this term here. And you would think that you would subtract these two numbers, which is fine. 30 minus 5 is 25, but that's not the total number of terms you're trying to add together. You're trying to add a total terms of 26. You've always got to add 1. So 30 minus 5 is 25 plus 1. So I know now that the total is 26. I know my first term is what? 30. I know that my second term is, or my last term, excuse me, which is term 26, is 5. So I'm ready to find the sum. This is an arithmetic series, is it not? Plus a negative 1, plus a negative 1, plus a you're adding the same number over and over. So S subscript n equals n over 2, a1 plus an. So here we go. I'm finding the sum of how many terms? 26 equals 26 over 2. First term is 30, last term is 5. So 26 divided by 2 is 13 times 35, 30 plus 5. So 13 times 35 would be 455 poles. You've been troopers today. I warned you it'd be an extremely long video. However, you have no homework over the weekend, so enjoy that. But please study for your quiz. I will email you your quiz on Saturday. Please work on it, study, be ready for it. You must have it in my hands, totally done, completed, all questions asked and completed by Wednesday. Okay? Have a good day. Call me or email me if you have any questions.